Good afternoon, my YouTube viewers. It is Crystal here. I'm just here this afternoon because I wanted to give you another code review. This code review is going to be on the breast cancer dataset again, but what we're going to be talking about is the agglomerative clustering technique used to make clusters on the breast cancer dataset. So in the last video, we talked about the breast cancer dataset. So I'm just going to really briefly skim through what I've done in the breast cancer data set because I don't want to, just make all of the information that I'm quoting redundant by saying it over again. But the first thing I did was I created the program in Google Colab, which is a free online Jupyter notebook. And it's a great platform to use. I would highly recommend anybody use it. The only disadvantage is that it does not have an adequate undo function, so you need to be careful not to overwrite or delete any valuable code. But if you do happen to delete some valuable code, you can go into the save history, and maybe there's a possibility that you may be able to retrieve the code in the save history. So that's one way that you can get your code back, but it's not any guarantee that you'll get it back, but you can give it a try. So you need to be very careful when you're typing in data not to overwrite it or delete it, and you need to be very careful when you're saving data, because one time I was working on a program on another computer and it didn't save properly, and which meant that I lost that data. So if you're going to work on another computer, make sure that it has saved properly, otherwise you will lose the data. After we created the after we created the program, we will import the libraries, and the libraries that we're importing for this program are NumPy, Pandas, Seaborn, Matplotlib, and sklearn. And so after we've imported the libraries, we're going to read the data set. So in this particular program, we're using sklearn's toy data set, the breast cancer data set. So we've already talked about that in the last video, so we're just going to skim through everything that we did, except for to say that we analyzed the target, and when we analyzed the target, we found that you had more ones than zeros. So I'm assuming that a 1 is that they had breast cancer, and a 0 is that they didn't. I made a little heat map so you can see how the columns correlate with each other. There was a high correlation in the columns, and since there was a high correlation in the columns, I inserted rows to delete the columns that had over 90% correlation. So I was able to reduce the number of columns from 31 down to 21. I created my training and my validation sets. And then after I created the training and validation sets, I selected my models. And it's really interesting because K-means is a really popular model. And when I did it this morning, for some reason, K-means had an accuracy of 84%. And I'm not sure exactly what happened, but when I reran it this afternoon, its accuracy decreased from 84% to 15%, so that's not very good. And then we tried our mini batch k-means, and that was 18%. So mini batch k-means performed a little bit better than k-means. And then so we tried the affinity propagation, which had a very poor accuracy. We tried the agglomerative clustering, which is what we're going to be talking about now, and it had an 83.2% accuracy. And then you notice that in the earlier video I made, we were doing Birch. We were making a code review on Birch, and Birch had 83.2% accuracy. Check DB scan. dbScan had a 0 accuracy. We checked mean shift. Mean shift had a very low % accuracy as well. We checked optics. So optics had a low accuracy. We checked spectral clustering. And spectral clustering had a 38% accuracy, so it was actually better than k-means. And then we checked Gaussian mixture, had a very low accuracy. So we're going to go back to the agglomerative, which is what this code review is on. But what I wanted to do was I wanted to show you the accuracies of the other models before I showed you the agglomerative. So here we are back in agglomerative, and that's what this code review is about, but I did want you to see the other models. So from sklearn.cluster import agglomerative clustering. Clustering equals agglomerative clustering. In clusters equals 2 brackets dot fit x train. Then y hat equals clustering dot fit predict x train. So you can see y hat is a bunch of 1s and 0s. And predictions equals clustering dot labels. And then the predictions is a bunch of 1s and 0s. So we have 2 clustering. Clustering dot in clusters equals 2. Len of clustering dot labels equals 512. Type clustering.labels is a NumPy array. And then what we do is unique comma counts equals np unique comma clustering.labels comma return counts equals true. And then so you put that in a dictionary. So dict brackets zip brackets unique counts. So you put it in a dictionary and you zip the unique and the counts together. So you have 174 zeros and 338 ones. So clusters equals np unique y hat, and that's an array 0 and 1. And then we check the accuracy of that, and it's 83.2% accuracy. And we plot it on a graph, and so you can see the zeros and the ones when we plot it on the graph. But this had this 83.2 had the same accuracy that Birch had, but I wanted to go ahead and do a code review on this. And this is an example, so like an illustration of the fact that whenever you are trying to cluster data, you set up several models, and then you can select the model that gives you the highest degree of accuracy. So in this particular instance, k-means didn't do very well, but Birch did well, and agglomerative clustering went well. So that's about it for this video. I just wanted to show you agglomerative clustering, and I wanted to show you the code for that. So I'm going to go ahead and conclude this video. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching this video, and I look forward to making more videos for you in the future.